So, about the carbohydrate digestion, as we said, it will start in the mouth by enzyme, which is the salivary amylase, and also it will be continued in the small intestine with the enzyme of pancreatic amylase. In the stomach, there is no chemical digestion there is no digestion for the carbohydrate by enzyme, but there is a breakdown and some hydrolysis will be there by the HCl. In the small intestine, intestinal enzyme, which is the oligosaccharide, it will change. So the starch here, it will be changed to oligosaccharides by the salivary amylase and pancreatic amylase. Then in the small intestine, it will be break down to maltose and glucose by the intestinal enzymes. About also the lactose, starch, and saccharose. Saccharose, it will remain as it is. It will be passing until it reach the intestinal enzyme. So it will be as saccharose, the same starch, oligosaccharides, as we said, then maltose, then it will be changed to glucose. The lactose, by the intestinal enzyme, it will be to lactose, and it will be lactose as the same. So this is the action of what will happen to the carbohydrate in our digestive system. The absorption, monosaccharides, it will enter the capillary villi, are transported to the liver via the hepatic portal vein. So it will be transferred to the hepatic portal vein and then to the liver. About the protein stuff, in the mouth there is nothing, there is no enzyme, just breaking down of the food to small pieces by the mechanical action. In the stomach, the pepsin and the presence of the HCl in the stomach, it will break down the large polypeptide to a smaller polypeptide by those enzymes, those action. Then the pancreatic enzyme, it will change the large polypeptides to smaller polypeptides and smaller peptides. Then the intestinal enzyme, it will change it to amino acid. It will be changed to amino acid. So from protein, it will be going to large polypeptides by breaking down of it by the pepsin and HCl action. By the pancreatic enzyme, it will be small polypeptides and peptidates. Intestinal enzyme, it will change them to amino acid. You took that also in biochemistry. So the absorption of monosaccharides enter the capillaries. This is the monosaccharides, as we said, then transported by the hepatic vein. About the lipid, there is nothing happened to the lipid inside the mouth or inside the stomach, just it is a mechanical digestion. A mechanical digestion. The chemical digestion, it will start in the duodenum. So emulsification of fat by the bile salt, by the excretion of the bile salt, and the pancreatic enzyme, it will break down the emulsified fat to monoglycoside and fatty acid and glycerol. and fatty acid. So it will be break down by the pancreatic enzyme, which is the lipase, to monoglyceride and a fatty acid, and glycerol and fatty acid, in order to prepare it for the absorption. Absorption mainly through the lactate and transported in the lymph to the systemic circulation, then to the liver. This is for the fat. So, just to remind you with what we said before, what is the function of the parasympathetic nervous system in relation to the digestive system? This thing we discussed it in the beginning of the previous session. So, the parasympathetic, what's the effect of parasympathetic in the process of digestion? Increase what?
The digestion.
How?
Absorb. When feel the fear.
No?
When feel the fear.
When feel?
The fear or emergency situation.
Digestion. You are relaxed and sit. Now there is no fear. We are not discussing the fear. Yes, it has a function with a fear, but now we are discussing the taking food and the effect on digestive system.
Increase to absorb the enzyme.
What are the things that stimulate the parasympathetic system in order to increase the secretion of the enzyme and secretion? Before food, the smell of the food first. The smell and the scene. When you see something which is look delicious, look arranged well, look that it is cooked well, this will stimulate the digestive system. But if you saw something which is not nice for eating, sometimes you feel that you want to vomit. Instead of stimulation of the, it will be stimulated for vomiting. By the way, for the process of vomiting, do you know how vomiting will happen? Vomiting, in case if there is an irritant food, or in case if there is a bacteria or that irritates the gastrointestinal tract. In this case, there will be the backward reflex, that the movement instead of the contraction will be in backward action. So the pylorus will close, the stomach will contract, the cardiac orifice will open, and the food will be ejected outside in this case, which is a reflex that you are getting out the food which is there and it is in your stomach, and it might be harmful for you. So instead of passing it through your GI tract, it will be rejected and it will be vomited by this action. Also, what's the thing that will stimulate vomiting? When you feel that you want to vomit, even without, if it is not related, if you took a food and the food is good, but there are some stimulant that it will stimulate vomiting. If you smell something, no, we are with the stimulant. If you smell something bad smell, sometimes you feel that you want to vomit in case of bad smell. So it will stimulate the contraction of the stomach and the gastrointestinal tract to reject the food which is there inside. even if there is no food inside, in this case, gastric secretion will come out. So it will control the resting and digesting by stimulating, as we said, stimulation of the sympathetic, of the parasympathetic system through the smell. So the stimuli, the mechanical stretch of the receptor, it will stimulate and monitor the stretch of the lumen. Also, the chemoreceptor, so there are many stimulants that stimulate the GI tract. One of them, the parasympathetic. Then also the mechanical, which is monitor the stretching of the lumen. When we eat food, that food, when it is coming to the lumen of the alimentary tract, of the alimentary canal, it will lead to stretching of the wall. That stretching of the wall also, it will increase the secretion and increase the process, start the process of digestion. The chemoreceptors also, the chemoreceptor which is there in the lumen, which also contain the pH and production of digestion, it will lead to production of that. So for each substances, there are receptors, there are a sensor there that will sense what kind of substance which is there. Because of that, when the food is coming to the duodenum, that receptors will check the amount of fat, the amount of protein, the amount of carbohydrate there, in order to excrete a sufficient amount of enzyme, which is able to digest them and to breaking them chemically to a simplest form. There is a effector which is the gland stimulate or inhibit the secretion. We are not, for the whole day, we are not taking food for the whole time of our day. So if the stimulation is there and the excretion is there always, in this case, what will happen? When our stomach is empty and the excretion is becoming more, then it will affect the mucus lining of the gastrointestinal tract. So when the gastrointestinal tract is empty, in this case there is inhibiting hormones that inhibit the excretion of digestive juices. So it will decrease, it will suppress the excretion of digestive juices. So the digestive juices, it will be increased by the presence of the food and by the stimulation when we sit for taking the food and see the type of food, when we smell, when we are going back home and we smell the food, that good smell of the food, in this case, it will be stimulating and gastric excretion will start. But when our gastrointestinal tract is empty, in this case, instead of excretion, there will be inhibiting hormones that will inhibit the secretion in order not to affect the gastrointestinal wall. So the effector will in the gland and the stomach, also muscle and organs walls. This is just repetition of what we said. So the ingestion of food, which is and breaking down to small pieces and chewing, salivary amylase, and that is effect. The propulsion and swallowing, how it is happened. And by the way, the process of swallowing is voluntary. But after that, all the processes, is it voluntary or involuntary?
Involuntary.
Involuntary. So all the processes is involuntary. The process of ingestion is voluntary. The process of defecation is voluntary. So the first part and the end is voluntary, but what's going in between, it is involuntary. We don't interfere with what is going in. It will work automatically without any type of voluntary action from our side. So this is again for the process of swallowing, how it's happened. So the biggest stimulator causes the chain event, which is the tongue block the of the mouth, and the soft palate will close the nasal passage or nasal cavity. Larynx raise up and covered by the epiglottis. The food move in the esophagus, and peristalsis propels in downwards. A pressure on the cardiac sphincter and esophageal sphincter will cause relaxation of it, so the food will go to the stomach, food enter the stomach there. As we said, no effect of the gravity is there in that swallow. So this is the how the swallowing happened again. The tongue is moving backward. This is the chewed food, and the soft palate will close the nasal cavity, and here there is, this is the hard palate and this is the soft palate. This is the tongue. This is the oropharynx and laryngopharynx. So in the laryngopharynx, it will close the respiratory tract, and the food will go toward the esophagus. Again, the regulation of breaking down of food, the parasympathetic response to slight smell of food and secretion and gastric juice, and which is when it is arrived, the pH will be raised, gastrin hormone will be excreted from the stomach gland, and it will be secreted more. 2 to 3 liters is there. The HCl activate the pepsin to pepsinogen to pepsin and begin protein digestion to a large polypeptides. So from carbohydrate, it will be large polypeptides, and then the renin for infant, it is for digestion of milk. Absorption nil, as we said, it is only for aspirin and alcohol. What's happened also mechanically, when the arrival of food, stretching of the wall, the 3 muscle layer become active, and bundle of food will be break to a part, small part. And this is, we call it the churning mixture, churning of the food with the gastric juices. So how we will churn that content of in order to make a block, or it is similar that we are churning the food particles with the mixture of the gastric secretion in order to make that mixture and to do the digestion for the protein. The result will be semi-liquid chyle. So it will be semi-liquid chyle. As we said, around 3 liters of secretion will be there from the stomach. After churning and mixing well, peristalsis will begin and the food will move toward the pylorus. This in the pylorus around 30 ml will be held there, then 3 ml will be going down to the duodenum, and it will stimulate the excretion from the bile and from the pancreas. So each wave will contract and open the sphincter about 3 ml of chyme squirt into the duodenum, and pylorus force remaining chyme backward for remixing. So the remaining amount of the 30, it will be going backward. So only 3 ml is going and the rest will be going back. In the duodenum, as we said, the stretching of the wall stimulate the reflexes and it will inhibit the vagus stimulation. Tightening of the pylorus will happen and slow emptying of the stomach. As we said, it will take around 4 to 6 hours until completion of the process of digestion. As we said, this is about the vomiting and what we reverse peristalsis occur in the stomach as a result of activation of emetic center in the medulla. The emetic center is there in the medulla. The stimulation of that, it has happened in case of many situations. There are many situations that will lead to vomiting. Either it is due to the presence of bad food or bacteria within the food in the stomach, so it is from the stomach itself. So it will, the reflex, it will go to the medulla and it will induce vomiting, or it might be due to pressure in the brain or pressure in the intracranial, increase in intracranial pressure, or it might be also due to vagal stimulation from a cardiac condition, from the condition that affect the heart. Because the vagus nerve, as we said before, it is supplying the heart and supply all the all through the gastrointestinal tract. The pancreatic enzyme, as we said, we have enzyme the pancreatic amylase. The action of it is the carbohydrate breaking down the trypsin and chemotrypsin and carboxypeptidase. The action of it is mostly on the protein breaking down. So for protein breaking down, we have pancreatic we have the trypsin and chemotrypsin and carboxypeptide. For the carbohydrate, we have the pancreatic amylase. For the lipid, we have the pancreatic lipase. There is also the brush border enzyme, we call it brush border enzyme, that lactase, maltase, and saccharase. Their action is on the double sugar. In the disaccharides, they will change the disaccharides to monosaccharides. Lactase for lactose, maltase for maltose, saccharase for saccharose. Those are the disaccharides. They will change them to monosaccharides in order to be absorbed. The pancreatic juice also, there is bicarbonate is there, which make the media alkaline, because the chyme which is coming from the stomach, it is highly acidic. If it remain highly acidic, it will digest the wall of the duodenum. If it remain as it is, it will digest the wall of the duodenum. So it will be neutralized by the alkaline secretion. The pH here is around 8. So need to working for the pancreatic enzyme also. It will needed that alkaline excretion in order to activate the enzyme of the pancreas to work well. The bile, as we said, it will emulsify fat and breaking it into droplets for lipase to the enzyme pancreatic lipase to work on. The pancreatic lipase will not be able to work on the fat while it is not emulsified, while it is not as emulsion. So first, the gallbladder salt, it will make it, it will be secreted and make it as an emulsion. Then the pancreatic lipase will work on it and will breaking it down in order to change it to a fatty acid. Need to absorption of fat, soluble vitamin also, it is needed for fat soluble vitamin to be absorbed, like اللي هي ADK. Control, we have the vagus nerve and the hormone. They are controlling the secretion. The hormone secretion stimulated by acid chyme and pancreatic juice output and bile. The cholecystine was stimulated by the fatty chyme, and as above, and also the gallbladder to contract. It will contract the gallbladder and excrete its secretion. So the stimulation by the vagal nerve fiber, which will cause to release the pancreatic juice, and chyme enter the duodenum, will cause the duodenum mucosal cell to release secretion, and the cholecystine and secretion enter the bloodstream upon the reaction on the pancreas. Cholecystine induce secretion of enzyme-rich pancreatic juice secretion, causing the secretion of reaction of bicarbonate and pancreatic juice. It will be there. So this is how the action will happen. The absorption, as we said, most of the absorption happened in the small intestine by the active transport. Most nutrients are absorbed in the blood capillaries. Fatty acid and glycerol are absorbed in both blood and lymphatic capillaries, and that occurs by passive diffusion. It will be passively diffusion. It will diffuse because the membrane is fatty, so it will diffuse there. The propulsion is the peristalsis wave all over the gastrointestinal tract. So this is mostly, we summarize again the enzymes and how they are acting on the gastrointestinal tract. Still, is there any question? Do you have any question? Anything that you want to expand and on that? Okay, thank you. We'll stop now. We'll have a break.